In this lesson, we are dividing rational expressions. We've just finished multiplying rational expressions, and so we know that division with fractions just means we multiply by the reciprocal. So good news is, if you understood multiplying rationals, then dividing should be very easy for you. Remember that division means multiplication by the reciprocal, so I'm simply going to flip that second one over and then proceed exactly like I did on our last lesson. So I'm going to restrict that domain to say that x cannot be 3 and x cannot be 0, and then I'm going to reduce anything I can. X minus 3's cancel, x's cancel, 2 reduces to 1, 4 reduces to 2. My result is I have a 2 on the top and nothing on the bottom, which is a 1. So 2 over 1 is just 2. So my answer is 2. My restriction is that x can't be 3 or 0. On this question, again, this is division, but the division just looks a little bit different. So don't let it fool you. It's really just like it was written like this, instead of as a fraction. So it's the exact same thing that we've been practicing. So let's go ahead and do our first step, which is of course to start our factoring. The numerator is a perfect cube plus a perfect cube. So I'm going to use sum of cubes, which is that pattern that says you take the cubed root of 2t and the cubed root of 3. And at first I'll add them, so 2t plus 3. And then the pattern says square this one, which gives me 4t squared. And then subtract the product of the two, which is 6t, and then add the last term squared, which is 9. The denominator of 9 minus 4t squared is a perfect square minus a perfect square, so that would be 3 minus 2t, 3 plus 2t. The next one, so this one, doesn't factor. So if I look at 4t squared and 9, it looks kind of like it's one of those perfect square ones. You could try the tic-tac-toe, but I'm going to save us the time. I've already tried. It doesn't factor. But notice I'm going to rewrite this as multiplication, and I'm going to write this now down below. So I'm going to write this as 4t squared minus 6t plus 9. And then this one will factor. And again, if you need to tic-tac-toe, just as a reminder, that 2t squared would go here, minus 3, which multiplies to minus 6t squared. The minus t would go here. I'm looking for numbers that multiply to negative 6 that add to negative 1, which would be negative 3 and positive 2. And then I would say that the 3 would have to be here with the 1 here, and the 2 would have to be here with a 1 here, which gives me t plus 1 in one diagonal and 2t minus 3 in the other. So far, this looks pretty good. Let's see what we can cancel. These two large trinomials cancel. And then I've got this situation here where I've got a 3 minus 2t and a 3 plus 2t. Well, this one, they're both positive, so this one's really the exact same thing as 2t plus 3. It's the same thing. So 2t plus 3 and 2t plus 3 will cancel. I didn't have to multiply that by a negative 1 because both of them were positive. However, 2t minus 3 and 3 minus 2t, I am going to rewrite this one as negative 1 and then 2t minus 3. Now I can reduce the 2t minus 3's, and on the top of my fraction I'm left with only t plus 1, and on the bottom of my fraction I'm left with only negative 1. Now we don't like to write fractions that involve negatives as a denominator, so I'm going to move that out front, but notice when I move it out front I don't really have a denominator because a denominator of 1 doesn't matter. So essentially I have negative 1 and t plus 1. And again, it might be easier just to go ahead and multiply this one out because it's just a 1 to negative t minus 1. Either one of those would probably be just fine. The restrictions on the domain, I kind of skipped over that. We know that t could not be negative 3/2 or positive 3/2, and that's it. Because this one, remember, didn't factor, so we didn't have to worry about it. So I basically set this equal to 0 and this equal to 0 and solved. For our next example, notice we have division, and my second value is not a fraction, so we're just going to think about it as being a numerator over 1. Again, I'm going to factor, so my first would factor, because it's a difference of squares pattern, would be 2x plus 3, 2x minus 3. My denominator is a perfect square, which would be 2x plus 3, 2x plus 3. Remember, if you don't know that it's a perfect square, it really doesn't matter. I would then go ahead and do my tic-tac-toe to find my factorization. Now for this, the division, I'm going to change it to multiplication, which means 1 over, and then that would reduce to 3, and then 2x minus 3. So I changed division to multiplication. I flipped the fraction upside down. Now I'm going to reduce. I've got a 2x plus 3 on top and on bottom, a 2x minus 3 on top and on bottom. That leaves me with a 1 as a numerator, and my denominator is 3 times the quantity of 2x plus 3. In terms of restricting my domain, I would look at all 3 of these. So x could not be negative 3/2, x could not be positive 3/2, and that's it. Here's one for you to try on your own, so please press pause, try the whole question, take your time, there's a lot of factorization going on, and then press play to see how you did. For the first, I'm going to rewrite that as x plus 1. So x times the quantity of x plus 1. I factored out a common factor of x. For my second, I would take an x squared out, which would leave me with 5x minus 1. This is division, so I'm going to change it to multiplication. I'm going to factor this one, which is a difference of squares pattern, which is 5x plus 1, 5x minus 1. And again, notice I've written that as the numerator because I have flipped it. And then I'm going to factor this one. I would start by taking a 2 out, which would give me 5x squared plus 6x plus 1. So the 2 would come down here. It looks like this one would factor into 5x and x, and then plus 1 and plus 1. And then I would, let's go ahead and restrict our domain right now. X couldn't be 0 because of this one. X couldn't be positive 1/5 because of this one. X couldn't be negative 1/5 because of this term. And x could not be negative 1. And that's how I would restrict my domain. So each value that is the denominator, I would restrict from there. I can cancel a 5x minus 1, a 5x plus 1, an x plus 1, and this is x to the first and this is x to the second, so I'm going to cancel one of the x's, which leaves me with just an x on the bottom. So on the top, I don't have anything, so I have 1. We can't just not write anything. On my denominator, I have an x and I have a 2, which means 1 over 2x.